Good morning, everybody. Oh, the mask is terrible. So give me a minute. I'm going to take attendance, let kids in.
Second time the charm. If it did, I would probably be.
We're block 5, right? Okay, so admit all. Okay, Chinmay is here. Nick is here. Nicholas. Wade is here. Casey's here. Deason's here. I've still got kids coming in. Siddhant is here. John Young is here. Jamie is not. Raval is here. Who else is here? Siddhant, Gil, Lily's here. Gabriel's here. Nathan's here. Vivian is not here. Yanni's here. Anna's here. Asa, Oliver. Cleo. Cindy is here. Gussie's not here. Victoria. Alex is here. Shandrika's here. Let's see. Jason, Gabriel.
Oh, yeah.
Gabriel. Alicia's here. Dina's here. Derek's here.
Yeah, most of it, because it's like you have reshot, and then you have Lena, and then you have
Let's see. Here's Gabriel.
Literally before the Iron Man had the
He's not here. Rebecca's here. Alex is not here.
Yeah, they're like blasting music.
Actually, I think I've got everybody. Okay, so how was your homework? Pretty mild. Any questions on it? Yeah, we're going to get some practice in for sure. So our agenda today, I know I didn't erase this from last time, but we're probably going to look at the chain rule a little bit more. You need to be very, very comfortable with that. And if you are, then we'll move into implicit differentiation, which is extremely important for using it to solve related rates problems, which is a huge, huge chunk of AP calculus. So related rates is one of the big applications of differentiation. So, but we'll see how you do. So let me unshare this, and I'm waiting for Rohit to come into the room. Was he supposed to make up a quiz?
The quiz is next class, right?
Yeah. So tomorrow for day 1 and Friday for day 2. And what I'm going to do is so I was talking with BC because they're pretty proficient at this stuff from last year. What they suggested was they're like, well, if we already have an A, why should we have to take another quiz? So they said, why don't you just do it for kids who want to get an A, who want to try and improve their grade? So that's what I'm going to do. I'm going to make the quiz only for those who want to improve their grade. If you're fine with your grade, if you have a C and you're good with that, you don't have to take it. But if you want to try and get a B, or if you have a B and you want to try and get an A, then by all means take it. And the deal will be that if it drops your grade, I'll keep your grade at what it was before you took the quiz. So I won't let your grade fall. I'll only use it to help you improve the grade. Capiche? So
Wait, so we don't have to take the quiz on Friday if we don't want to?
right. So if you have an A, you definitely don't have to take it. If you have a B and you want to try to get an A, then you'll want to take it, but you don't have to. So if you're happy with getting a B or a C or a D or an F in the class, then you don't have to take it. But if you want to try and bump your grade up to the next letter grade, then I would suggest you take it. It's not guaranteed to do it, but it could. So it's only going to be for those who want to improve their grade. You can't improve an A. Oh, I want a 98 and I have a 96. An A is an A is an A. So yeah. Let it go, okay? If you have an A, you don't need to take the quiz. So I'm not going to bog you down with any additional work at this point in time, because remember on Friday, my grades have to be submitted. Your report card grades have to be submitted through EDSB. So anywho, that's how we're going to do it. Capiche? I'll take that as a yes. Okay, so questions on the chain rule. Anybody want to go over any of the homework? Anybody? Really?
Can we do 21?
21, yeah.
21 and
19 and 21. Okay. So let's see, am I in the chain rule section? No. Here we go. So for number 19, you have f of x is equal to the tangent.
Oh, you're not sharing your.
Oh, shoot. Hang on, sorry. Share the screen. I don't know why when you press the button to share screen, it doesn't just automatically share the screen. You got to go through this rigmarole to share the screen. Like, how annoying is that? Let's see, is it going to work? There we go. Let me spin it. Come on, a little bit of a delay there. Okay, so the number 19 is tangent root x, and you want to find the derivative of that. So what's the outer function? Yeah. So what's the derivative of the tangent? Secant squared. So the derivative of the outer function is secant squared, but we're going to recompose it with the function inside, right? So this right here is your f prime g of x times, the rule says multiply it by the derivative of the inner function. Well, what's the inner function? Root x, right? This right here is your inner function. So, you want to think of it like this. So when you take the derivative, it's easy. And the derivative of the inner function is 1/2 x to the minus 1/2, right? This is your g prime of x.
Good morning, teachers and students. Sorry for the interruption. Teachers, there were passes for today's ACT school day tested passes that were delivered to your room. If those students are in your room, please send them to the gym. Again, teachers, there were ACT school day testing passes that were sent to your room. If those students are in your room, please send them to the gym at this time.
So this piece here is your g prime of x. And so if we put it all together, it's just secant squared root x over 2 root x. So in other words, if I rewrite this as 1 over 2 x to the positive 1/2, that reverts to 1 over 2 root x. So I'm just putting the root x downstairs. Is everybody okay with that? Oh, somebody's. Gussie. All right, and then for number 21, you have y equals x e to the 2x. So I cannot stress again until I'm blue in the face the importance of the chain rule. And the problem is that you're not going to get, so this problem was an easy problem. Most of them are going to be more complex than this one that I just wrote down here. because they're going to involve some kind of a product or a quotient, other things to do in addition to the chain rule. So here's the deal. You look at it from left to right and you say to yourself, self, what am I looking at? Is this a product? Is it a quotient? Is it something else? Well, this is clearly a product, right? You have this factor times this factor, right? So when that happens, what you have to do before anything else, what you must do, you know, there's a charging station up front too. It'll be there for another day. But anyway, you can put it back there. It's fine. So what you must do is you must employ the product or the quotient rule first. So we know that y prime is equal to x times e to the 2x prime plus e to the 2x times x prime. Is everybody okay with that? Hello?
You got a Rebecca copy?
I'm sorry?
I need Rebecca.
Oh. Anyway, I've employed the product rule, and what's going to happen is when you look at the factors that you have to take the derivative of, like this one, you notice that that's going to be a chain rule, right? Because I have e to the stuff, something other than just x in there, right? So what is the derivative of e to the 2x? Okay, so good thing I didn't give you a pop quiz just now. If you have e to the 2x, this is definitely a composite function. The outer function is e to the x. The inner function is 2x. Anytime you have, so look, you've got sine of x, cosine of x, tangent of x, e to the x, x to some number, or the square root of x, right? Those are the most basic functions. If I have anything in those exponents under the radicals in the parentheses, other than x, that means I need to use the chain rule, okay? Always. So here, I've definitely got something other than x in here. So my outer function is e to the x, my inner function is 2x, and now what I can do is I can take the derivative. The derivative of the outer function is e to the x. The derivative of the inner function is 2. And if I follow the chain rule, which says take the derivative of the outer function, recompose it with the inner function, and multiply that result by the derivative of the inner function, then what I have is e to the 2x times 2, or 2e to the 2x. Is that okay for everybody?
Somebody's in the waiting room.
Yeah, I'm admitting them. So the derivative here is 2e to the 2x plus e to the 2x, and over here the derivative of x is just 1. And now if I put that together, let me get rid of this. What I have is that the derivative is 2x e to the 2x plus e to the 2x, and you could factor out an e to the 2x and be left with 2x plus 1. And that's probably the way the answer was written in the book. Did we do the natural logs in here yet? A little bit. Okay. All right. Did we do this problem here? Did we do that one? Does it look familiar? Okay, so I want you to find y prime. I'll give you like 2 minutes to get that going. Find the derivative. Let me know when you get an answer. Anybody get an answer yet?
I did, but I can't guarantee that it's right.
Okay, what'd you get?
Y prime equals 3 root 2x times cosine 3x plus sine 3x over root 2x.
So did I write it down correctly? Over root 2x, you said?
Yes.
Did I write that down right?
Oh no, root first radical is 2x.
Oh, okay. Like that?
Hmm.
So we don't know yet. What rule did you employ first?
Product rule.
Excellent, the product rule, right? Because we have a product. So let's see, we've got y prime is equal to root 2x times the derivative of sine of 3x plus the sine of 3x times the derivative, and I'm going to write it as 2x to the 1/2. Is that okay? So now we're going to take our derivative. And for the first term, unfortunately, we have the chain rule, right? So the derivative of the outer function is, so the sine is the outer function, so its derivative is the cosine. We have to recompose it with the stuff inside. So you guys see what I'm doing? I'm just taking the derivative of the outside and I'm plugging in whatever's inside that function back in. Times, now what's the derivative of the stuff inside? 3, right? Plus the sine of 3x. And over here, when I take the derivative of this factor, I've got 1/2, chain rule again, times quantity 2x to the negative 1/2, times the derivative of the stuff inside, which would be 2, right? And what I see is that this 2 cancels with this 2, not that 2, okay? Don't ever do that. And so what we have, if I clean this up a little bit, I'm going to just bring this 3 up front. We're going to have 3 root x post 3x. And plus over here, you know, this is this 2x to the negative 1/2 is the same over 1 over the square root of 2x. Does everybody agree with that? So what we're going to have is plus sine of 3x in the numerator over root 2x in the denominator. So it looks like you get 100% there. Excellent job. This is an AP style question. Okay, and most of your functions again are going to be pretty busy. Yeah.
How do you go from root 2x to root x?
Oh, I forgot to write the 2. Sorry about that. It was there the whole time. Yeah, I do that a lot. My mind goes faster than my hand and my mouth. So anyway, always causes conflict. Here's another typical type problem. Y is equal to x plus 1 over x squared. Can you find y prime? Be not afraid. It's only a little fraction. An innocent little fraction.
Miss Wilson,
Mm-hmm.
can you check the chat box when you get a second? I asked you a
Sure.
question, but it's not really relevant to everything.
Yeah.
So.
Yes, she did. So that's fine.
Okay, thank you.
Uh-huh. Can we do 21 and 23? So I did 21 already. And this is 23. Was this a homework assignment? Did I give this to you?
Wasn't in the homework, but
Oh, okay. So this is 23 then. Did you guys get an answer already? Not yet. You guys need to speed up. Minutes. Anybody, anybody? What'd you get, Casey?
They have 2 times x plus 1 over the x. times
Two,
1
whoa. 2 times 1 plus
1 over x squared.
the quantity, like that?
Actually, it's minus.
Okay.
I read it different.
Uh-huh.
Okay, there's no, it's 1 over x squared, not the square at the end.
So is this multiplied by, is that what you're saying? Or is there a plus, or I'm not following you? So is this part right here so far?
No.
Oh. I'm sorry. I misunderstood. Okay, go ahead.
Okay, 2 times x plus 1 over x
Mm-hmm.
times 1 minus 1 over x squared. The squared is under the 1.
Oh, x squared. So like that.
Yes.
It's terrible. Uh-huh. Is that it?
Yeah.
Okay. Anybody else get that answer? Anybody else get something else? Yeah. You did?
Yeah.
Oh, okay. So let's see. Chain rule right away, right? This isn't a product or a quotient. It's just something raised to a power. So it's chain rule. It's stuff in parentheses, right? So the derivative of the outer function would be, I'm going to use the power rule, right? So again, whenever you have something in parentheses raised to a power, think of the whole thing as x raised to that power, and then use the power rule. So we've got, I'm going to bring this 2 down front. So we're going to have 2 times the stuff inside. This is the derivative of the outside recomposed with the inside. If I subtract 1 from this power here, I get a 1 up here, so we don't write it. And now we have to take the derivative of the stuff inside, right? And the derivative of x is 1 plus, now this can be written as x to the minus 1. So its derivative is negative x to the minus 2, right? So I'm going to change this sign here because this negative is going to make this negative. So happiness and joy, very good. Wasn't so bad, was it? It looks scarier than it is. One more. Y is equal to x squared minus 1 over x cubed. Find y prime. I'm hoping that some of you start to do this mentally, like right now. If you don't, it's okay. You'll get there, either with me or somebody else. So I'm seeing, I think that some of you are finished in the classroom anyway already. That's good. What about online? Anybody finished yet? I'm going to show you what I do. Is that what you guys got? Very excellent. The chain rule. Now, the derivative of the natural log of x is 1 over x. Very important rule to know. The derivative of the natural log of x is 1 over x. So if you have something such as y equals natural log of 3x, this is definitely a composite, right? It's not ln x, it's ln with stuff plugged inside of x, right? So it's definitely a composite function. And the question is, can you figure out what y prime equals to? Casey's nodding yes. That's what he got. Anybody else get 1 over x? Good, good, good. The derivative of the outer function, which is the ln, because it's outside of the parentheses or the radical or whatever, is 1 over x, right? But what are we going to replace the x with? Good. And now what's the derivative of the stuff inside? 3. And so those 3's will cancel and you get 1 over x. What about ln of 2x? What do you suppose that derivative is going to be? Yeah. Why? Because you're going to have 1 over 2x times 2. Okay. So anything of that pattern is pretty simple. Kind of like e to the 2x is going to be 2e to the 2x, right? Or e to the 3x is going to be 3e to the 3x. ln and e go hand in hand. What about f of x equals ln x quantity squared? What's the outer function now? I can't hear you. Victoria, what's the outer function?
X squared.
Good, x squared, right? Perfecto. So remember, when I have parentheses raised to a power, I make the parentheses an x. That's your outer function, always. So the derivative of that thing means we're going to bring the 2 down, and instead of putting an x there, we're going to put, why can't I talk? Recompose it with x, ln x. Subtract 1 from the exponent, and now take the derivative of the inside, which is 1 over x, right? So the derivative would be 2 ln x over x. Are we okay with that? All right. That being said, let me give you one more. Y equals ln sine of x. I propose that the derivative is going to be 1 over the sine of x times the cosine of x. You all agree with me? Derivative of the outside is 1 over x, but we're going to replace the x with the stuff inside, times derivative of the sine is the cosine. What's the cosine of x over the sine of x equal to? cotangent of x. Very good. So another way in which you would have to employ your trig identities. All right, so now I'm going to give you a doozy, but I think you can handle it. Y equals the natural log of 2x plus 3 over x squared plus 4. Find y prime. I'll keep playing Candy Crush while I wait. See if I can get to the next level. I hope you guys are bored. It's hard staring at boring, ugly white walls, and I feel like I'm in a jail cell in here. Probably a jail cell's not this bad, huh? I don't know. I've never been to one. So did anybody get, no. Anybody get this answer here? Close? That's good. It's okay to make a mistake, but just not on a test. So let's look at it again. I'm going to erase because I'm bored and I like to write. So I actually don't like to write. But so look, I know that the derivative of the outer function is 1 over x, but I have to replace the x with all of that mess inside, right? So I'm going to do that. And I have to multiply that by the derivative of the stuff inside. It just so happens that the stuff inside is a quotient, right? That means I have to use the quotient rule. And how I use the quotient rule may be very different from how you use the quotient rule. I'm still using the same idea. I just do it faster. What I do is I say, because it's imperative, critical, very important that whenever you use the quotient rule, you must take the derivative of what's in the numerator first, okay? So using the quotient rule, it's the derivative of the numerator times the denominator minus the stuff in the numerator times the derivative of the denominator all over denominator squared. Is everybody okay with that? Everybody following what I'm doing? People at home, you're being extremely quiet, and my crystal ball's not here, so I can't read your minds, but perhaps I'm going to have to start calling on you in mass. This piece right here, this factor, is a complex fraction. It's 1 over this mess. So if I flip it, what I get is x squared plus 4 over 2x plus 3. One and done, okay? I'm just flipping this upside down. If I distribute up here, if I clean up this numerator in this fraction on the right, I'm going to have 2x squared plus 8 minus 4x squared minus 6x. Again, being very careful to distribute that negative to every term in here. You could distribute it to the 2x first and then multiply, whatever floats your boat, okay? It's personal preference. Since it's multiplication, it's commutative, so it doesn't matter. Over the denominator squared. And what I notice right away is that I've got a factor in this numerator here that cancels with one of the factors in the denominator over here, right? And I can cross cancel because it's multiplication. And if I clean up the numerator a little bit more, over here, I'm going to have negative 2x squared minus 6x plus 8. So I'm just writing it in descending order. And if I factor that out, and I can, there's nothing that's going to cancel with either one of these denominators. So I'm not going to bother. So what I have is negative 2x squared minus 6x plus 8 over 2x plus 3 times x squared plus 4. And you would not expand that out. You just leave it alone. Any questions? Alice, I'm going to call on you next for your chat message. So what I think I'm going to have you do, because I'm not convinced that you're 100% with this, is I'm going to have you do a little bit more chain rule. I'm going to have you do page 224, which is 25 through 33 odd. And in addition to that, if you look at your Canvas, so let's see what's up here with Canvas. We're in block 5, right? So if you look under assignments, any day, Canvas, any day. There we go. Now, on the iPad, this is strange. What is this description thing here? Oh, that's me. Okay. So if you look in the left corner here, which I cannot highlight because the pen doesn't work. I mean, it works, but over in this section up here, up at the top, well, under the chapter 4 quiz anyway. Oh, it's not there. The more I'm working with Canvas, this version. Yeah, go ahead.
Is it under modules?
See, maybe I accidentally put it there. Let's see. Assignments. Or maybe I just didn't copy it over to you guys yet, because actually I think I didn't copy it over to you guys yet because you guys seem to be ahead of the other AB classes as far as pace. So let me go to block 3. I'm going to show you block 3s, and I'm going to show you what I'm going to copy over. So in block 3, they had yesterday, they did some more chain rule. And what I want you to see is, you see over here on the upper right here, says 4-4 part 2, and then chain rule worksheet. So there's an extra worksheet that I'm going to copy in just a second that I want you to do for extra practice. And if you, oh, I don't know if I can open it on here. Let's see. Yes, I can. So it starts off pretty simple here with some basic little chain rules. And then as you see me scrolling, you see they become more complex. If you can do these with relative ease, then you're golden on the chain rule. And that's my main goal at this point, is to make sure you're good with the chain rule. So you're going to have both of these to do. I'm going to have you finish up section 4.4 part 2 in class right now. That way, if you have questions, you can ask me. And so, you know, if you've got a C or a D, and thankfully there are very few, but some of you do. Some of you have a D because you don't freaking turn in homework. But if you have a lower score than you would like in the class, now is your time to say, hey, I need some help with this, or can you do a couple more examples with that, because I need extra help, and I'll be more than happy to do that. Also, I had to put a note to self. Yesterday, I posted an announcement to join my remind.com account because I'm going to work with you guys behind the scenes, because I don't know when or if you're going to get a teacher. And if you do, I don't know if that teacher is going to be good at calculus or not. If they're not, so imagine being a teacher. Imagine one of you guys, even one of the good students, like who really gets it. Imagine trying to go in and teach a class of kids with understanding and the depth and blah, blah, blah about the chain rule. Guess what? Teachers who don't know calculus do the same thing. They don't do it very good. So I'm going to be working with you behind the scenes as much as is humanly possible. And if you have a question about something, or if I'm going to do a live review on YouTube or something, then I'm going to post it on Remind. If you don't have, if you don't sign up for the account, you're not going to know. Or if you say, well, that's okay, my friend has one, so I'll just get it from my friend. Well, if I send you something or need to show you something, you're not going to be able to see it if I post it on there. So, yeah.
Are you posting a remind code, or is there already one for this class?
There's already one for the class. So if you go to the announcements page in your block, I don't know if announcements show. Yeah, they do. Let's see. It says, I think it's the second one down. Join Remind. Now this is the same code because this is block 3. So I put all of AB. Somebody just joined. I just got a beep. This is the same code for all of the AB classes. And another one. My phone's going to be doing that all day. Just sign up. The passcode's right here. It's real simple. And that way we can keep in contact with each other, and I can help you. Oh, yeah. The other thing I didn't announce, well, I did announce it, but I don't know if you read it, because some of y'all never look at Canvas. AP exams, they announced yesterday, I got the email, that they're going to test you online. That is not cool.
I thought they said they were never doing that.
They did, and now they changed it because they said that they received reports from the CDC that in the winter, the COVID rates are supposed to triple or something like that. And as a result, they don't want to take any chances. And so they're putting all of their work online. AP is a money-making gig. They don't care about me. They don't care about you. They care about making dinero. All right. That's the name of the game. So, and it's really sad, but it's true. I really don't care that much for AP, in case you haven't noticed. But, you know, they've got their claws in the America's school system, so we go with it. But the thing is that the problem with it is that the kids in BC who took it last year, they said they would have much rather have had the 3.5-hour test, because you got like 2 questions with like 6 parts each that kind of covered a few topics. And if one of those topics is one that you're not well versed in, you failed the test. I mean, there's no ands, ifs, or buts about it. So I'm really not happy about that. Now, maybe they'll change it so it becomes a 3-hour test. Maybe they'll give you some multiple choice, and maybe they'll add more to this test. I don't know. But if it's anything like last year's test, it's going to be a
They might have
nightmare.
made it so short last year because it was under such short notice.
Right, it was short notice. So I'm hoping that maybe they will redesign that. Because yeah, it was not good last year. So just letting you know that it is going to be out online from at home, and hope it all works out. That's all I can say. Really shocked that they changed their mind, because they were very adamant about the fact that it was going to go back to normal this year. But apparently COVID's supposed to get worse. And so anyway, that's the deal with that. So just letting you know, you should always read your announcements, because I only post them when they're really important. And what else? Okay, so we're going to have quizzes only for kids who have less than an A, if they choose to take it. Again, if you have a B and you're fine with the B, then you'll get your B. It will not lower your grade. It can only help your grade. So the worst case scenario, if you take the quiz and bomb it, you'll keep the grade that you have. I'm not going to like reduce grades at the last minute. Oh. Let's see who
Is the
that
quiz gonna be
someone
on chain
is.
rule or all of chapter 4?
No, it's going to be, hang on, let me see if there's Rohit's here. It's going to be on product rule, quotient rule. And all the other basic rules follow through, I mean, in those, but it'll be product and quotient rule. Rohit, let me turn on your camera for me, Rohit.
Wait, so it's product and quotient rule, does that include like using it in chain rule, or we're not even doing any sort of chain rules?
Chain rule would only be a bonus question. So it's product rule and quotient rule, plus all the basic. So in other words, you can't have a product rule or quotient rule without knowing basic derivative rules. So you already know those, right?
Yeah.
But the quiz or test will focus on those 2 rules. And maybe you'll have a small chain rule as a bonus. 25 through 33 odd. I guess I didn't say that. And in the worksheet, let me transfer that. So Rohit, give me just a second. Let me transfer that over right now so I don't forget, because you know how I forget things. Senior moment. Let's see. So let's transfer this over. Copy to block 5. And the worksheet, copy to block 5. And let me make sure it copied. And let me change the due date.
I'm sure you probably have.
So the due date on this is going to be Friday morning at 8:30. It's going to be the last thing I take from you guys. What did I say again? 30 what through what? What through what? 20. 25 through
25
33
through
odd, is that what I said?
Yeah.
I couldn't see the book and I just wanted to get this done. So online submission, it'll be due at Friday at 8:30 in the morning, so I can get it graded before grades. And the same is true with the worksheet. Chain rule worksheet. And what I would expect is that you would get the ones, so are you guys listening? The ones on the book page, and I'll project them. Those you should be able to get done in class and uploaded now, so you don't have a double burden. But let me go to the book and I will project, let's see, this is 4.4, right? 4.3. I have too many things in here. 4.4. Oh, that beautiful mathematics. Oh, no, that's implicit. You don't want that yet. You do not want implicit here. Okay, so you should be able to do these before the bell rings. Yeah.
25 to 33 pod,
I'm sorry.
25 to 33 pod.
Right. And let's see, let me just change the date and time, so to 8:30 a.m. Make sure you submit it, because if you don't, you're going to get zeros. And I would hate to give zeros on my last day before I close out the grades, but I will if I need to. I have no problem with that. I just don't like it. All right, so Rohit, let me find your camera. There you are. And I am going to email you the quiz in Canvas, and I'll need you to turn your camera on right now. Rohit, you're in block 1 normally, right? Hello? Rohit, are you there? Rohit. I can't send you anything until you answer me, so I'll wait.
On like Monday, should we just come here?
Mm-hmm. I haven't heard anything. I asked them, I said, what can I tell my kids? What is going to happen to them, with them? What can they expect? Nobody knows anything, which doesn't surprise me, which is why I'm going on my merry way. Yeah. So I would say just come here. If they're going to disperse you guys to other classrooms, there'll probably be a sign on the door, whatever. But I'm really sorry. I tried to find out and nobody knows anything. Just blows my mind. I'm not talking about anybody. Oh yeah, I heard that he was going to teach.
Yeah, he offered to take, because this is the off period, so he offered to take at least one of them, because he used to teach calculus. At least until they get like a real teacher.
Yeah.
So that we know someone, like if we're struggling, like he can at least help us through.
Right.
He said like he doesn't really know the curriculum, so he doesn't want to like say he's gonna teach, but he can do the problems if we're like struggling. So I was like, that would be good. So
Yeah, it would
I don't know
be.
if they're gonna give it to him, but if they do, then it would only be for this class. This is only
Oh, right. So not the other
yeah, the other kids
classes.
wouldn't.
Well, I'll be online teaching. I just have to figure out, so Monday I'll know what my work hours are. I think, like I said, I think I'm going to try and make my work hours from like 9 to 4. Nice, like banker's hours. And then, so I'll be able to work with you guys in the early evening or on weekends. At least if you can't meet, I could do a YouTube video and post them. I'm not gonna have access to your Canvas. That's why I need, a way of communication. So ergo the Remind account, but I can at least let you know when I post a YouTube video on what topic. And if you know the topic, you don't have to worry about it. And if you want to get some extra practice, you can.
Ms. Wilson,
Yeah.
are you the only teacher that teaches handicap BC?
Yes. They need to find somebody who's proficient in BC because it's hard to find a BC, somebody who understands BC. BC is a tough topic. And yeah, it's really important that the teacher who comes in knows mathematics inside and out. Because I know that some teachers, I heard, watch videos to learn how to teach and then teach the class based off a video. And I'm like, oh my God. So I'm very concerned about that, but yeah, we need a BC teacher. And I hope that there's one in the pool that wants to come to Middleton. However, what I don't know is how long a teacher of that caliber would last. And I'm saying that because it is. It's not the kids at all. It's just craziness from downstairs.
They're very unorganized.
The most inefficient, disorganized. I've just never seen anything like it. And it's very hard to deal with when you have to operate in that world. And that's the realm that I need to operate in. So anything they tell me to do, I do it. And then it's like, well, we changed our minds. Now do this. Come on. So we waste a lot of time. And I don't have time to waste. So anyway, if somebody wants to waste my time, they can do it from the comfort of my home. I'll go grab a cup of coffee and pet my dog. So Rohit, I need you to turn on your video. And I'm going to email you the quiz once your video comes up so I can see you.
Do you want to see the work or do you want to see me?
No, I need to see you while you're taking the test. So I need your video on. And I need to be able to see your hands and your paper. Yeah, I'll go.
Have it on.
Are you on? Okay, let me find. Yeah. Give me 1 second. I'll go over number 25. There you are. Okay, perfect. Okay, so what I'm going to do is I need you to go into Canvas because I'm going to email you the quiz because I can't upload it from Zoom. So let me do that right this instant. So Rohit, there you are. New message, quiz, attach the quiz. Okay. And, oh, this is so annoying. Block 1 to Rohit. I always have to choose the block. I don't know why, but anyway. All right, now let me know once it's open because I have to time you for 30 minutes.
All right.
And those of you online, I'm going to mute my microphone so he can have silence.
So remember elementary is 1 over x. Is 1 over x. So you plug that into it. So it would be 1 over So where's the next one?
Did it open up yet, Rohit?
I'm opening Canvas right now.
Okay.
So it would look like that, but that's weird. It's when you divide the denominator, you just put this in.
No, the assignments I meant to make due on Friday. I copied them from block 3, whose is due tomorrow, so just ignore that. I won't mark them late. Yeah, I'll write the work. I'll do the problem out silently on the iPad. Is it not open yet, Rohit? Because this is taking a little bit long.
My computer is frozen, so I'm trying to fix my Chrome browser. It's frozen.
Well, the thing is that class ends in less than 30 minutes, so I've got duty to do. So I need you to get on the ball. I need you to get this thing opened and get started.
Yeah, I got it now.
You got it? Okay, so
Yeah.
time begins then at 9:38. Good luck. Okay, so number 25.
Pressure on the bottom of the side. So you write like this. That's the same thing, the same inches squared with the top. Divide the bottom. So we can't divide. So this will take the pressure, this will go back on the top. Fraction. Okay. So that's why you write like that. Just like this first. Then after that, you want to take the derivative inside. So the derivative to the inside. So you want to use the quotient. So you can do x plus 1.
That 25? I did it. Oh. Sorry, I got that bar thing. That too, right? So. Can you still read it?
Yeah.
Right. That's what. Oh, you're looking at it from reciprocal. Look at the other one.
I don't know how to use reactions in Zoom. Oh. I see. Rohit, once you've finished, you're going to upload your work into Canvas. Or don't upload it, email it to me. Sorry, take a picture and email it to me.
Am I allowed to use a calculator for summer fifth?
No, there's no notes or calculators allowed.
Okay.
Okay, everybody online except for Rohit, you may sign out. Bell's gonna ring in a couple minutes. Rohit, you have till 10:08 to get your work uploaded.
Is it okay if I go get my phone to take pictures?
Yes. Did it send?
Miss Wilson?
Yeah.
Well,
Yeah, I'm here. Did you send it? Rohit?